Hi, this is Wendy Lightheart, and today we're starting Chapter 6, which is on factoring polynomials. And the first topic we'll be looking at is the greatest common factor, and then we will also be looking at factoring by grouping. The greatest common factor, and from now on we'll call that the GCF, is an expression of the highest degree that evenly divides each term of the polynomial. To find the GCF of a polynomial, first find the GCF of the coefficients, or in other words, the biggest number that will divide each coefficient evenly. And then our second step is to check to see if every term has the variable. If so, then the GCF will include the lowest power of that variable. The third step is to put these two results together. The GCF of the polynomial is the product of these two results. So let's look at some examples. Here's a polynomial, 6x plus 8x squared. So we're first going to look at the coefficients. The GCF of the coefficients, 6 and 8, is 2, since 2 is the biggest number that will divide both 6 and 8 evenly. Our second step is to verify that both terms have the variable. Both of these terms do indeed have an x, so we're going to take the one that has the lowest power. So the variable part of the GCF is going to be x, which comes from the term 6x. Then we put those two together with multiplication to get our GCF, and so the GCF of 6x plus 8x squared is 2x. And this is the expression of the highest degree that divides each of the terms of the polynomial evenly. So now we're going to look at how do we factor out the GCF from a polynomial. Our first step is to first find the greatest common factor. Then we express each term as the product of the GCF and its other factor. Eventually you should be able to skip this step. The third step is to use the distributive property, the opposite direction that you're used to using it, to factor out the GCF. So here's our first example. We're going to factor 7x squared plus 28x by factoring out the GCF. So first we have to find the GCF. So if you look at the coefficients, the GCF of the coefficients is 7, and then they both have x's, and so x to the 1 will be the lowest degree. So we're going to take the 7 and the x to get our GCF. Then we're going to express each term as the product of the GCF and its other factor. So we're basically factoring out the GCF out of each term individually first. So with the 7x squared, that becomes 7x times x. So again, we're factoring out that GCF from that term, and x is the other factor. Then we do the same thing to 28x. We factor that as 7x times 4, where 4 is the other factor. Now we're going to use the distributive property. We're going to pull that GCF out front of a set of parentheses, and the other factors that are remaining will go inside the parentheses, along with the operation symbol. Notice that if you distributed the 7x back through, you would end up with the expression that we started with. And that's a great way to check your answer. Let's look at another example. Here is a polynomial, and we are going to factor out the GCF from this polynomial. So the first thing is to find the GCF. So look at the coefficients. Determine what is the greatest common factor of 5, 10, and 25. And that's going to be 5. Then make sure that each term has a variable of x. Each term does in fact have a variable of x, so we take the one that has the lowest exponent. So that's going to be the x to the 1, which is from the 25x term. So 5 times x is our GCF. Next, we're going to express each term as the product of that GCF and its other factor. So we're going to write each term as 5x times whatever other factor is left. So the 5x to the 4th will become 5x times x to the 3rd, because x times x to the 3rd is x to the 4th since we add the exponents. And then with the 10x squared, it's negative 10x squared, so if we factor out a positive 5x, then the remaining factor is negative 2x. Then on the last term, if we factor out a 5x out of 25x, then the remaining factor will be 5. The next step is to factor this 5x out using the distributive property. So we're going to pull the 5x out front of a set of parentheses, and all the remaining factors go inside the parentheses in order. So we have x cubed from the first term, we have negative 2x from the second term, and plus 5 from the last term. So the GCF has been factored out. And notice if you distribute the GCF back through, you will get the polynomial you started with. Now we're going to look at how to factor by grouping, and grouping is used when you have a 4-term polynomial. So the first step for factoring by grouping is to group the first 2 terms together and the last 2 terms together. The next step is to factor out the GCF from each group separately, using the skills that we just went over. The third step is to factor out the remaining common binomial factor if one exists. This step will become more clear once we go through some examples. So here's our first example. We're going to factor this 4-term polynomial by grouping. So the first step is to group the first 2 terms and the last 2 terms. So there are the first 2 terms grouped together and the last 2 terms grouped together. You might notice that the textbook uses parentheses to do this grouping, but I prefer to use the brackets underneath, but that is up to you which grouping symbols you want to use. I think the parentheses can be a little bit confusing, so that's why I like to use the brackets, but then again it's up to you. So now we're going to factor out the GCF from each group. So the GCF of the first group would be a 3 from the coefficients and an x for the variable part. So 3x is the GCF from the first group. Notice we're going to skip that step of splitting up each term as the GCF times its remaining term and go right to the next step. So if we factor out the 3x using the distributive property, one way to do this is to think about what would have to go in the parentheses so that if you were to distribute the 3x back through, you would get 3x squared plus 6x back. So to get 3x, we would need an x, since 3x times x is 3x squared. Then to get a positive 6x, we would need a plus 2. So the GCF is now factored out of the first group. Now we need to factor out the GCF from the second group. So we'll pull out a positive 4 as the GCF. Notice there is no x part of the GCF since the 8 does not have an x on it. Then what we would need inside the parentheses to get 4x plus 8 back, if we distributed the 4, would be an x and then a plus 2. Now notice that we have an x plus 2 from the first group as a binomial factor and also in the second group. If the polynomial does in fact factor by grouping, then this should always be the case. Our next step is to factor out that remaining common binomial factor. So the common binomial factor again is the x plus 2. So we're going to do this just like we did the GCF. We'll pull that common binomial factor out front, outside a set of parentheses, and then what goes inside the set of parentheses next to it are the remaining factors. So the x plus 2 gets pulled out front, and then we have a second set of parentheses that has the 3x and the plus 4, which are the remaining factors. This polynomial is now factored. Let's look at another one. We're going to factor this by grouping. So the first step is to group the terms. We group the first two terms and the second two terms. And notice when I group the second two terms, I include that operation symbol because that's really a sign on that third term of that polynomial, which is the first term of that group. That's very important to remember. So now we're going to factor out the GCF from each group. In the first group, notice that there's a coefficient of 5 and a coefficient of -1. Those do not have a common factor, so there won't be any coefficient to factor out, but they both have an x, so we can pull out an x. So that'll be our GCF for the first group. And then what can we multiply x by to get 5x squared minus x? Well, we would need a 5x to get the 5x squared term, and we would need a -1 to get the negative x term. So the first group has now been factored. Now we're going to factor GCF out of the second group. Well, if you look at the coefficients of 15 and 3, you probably have already figured out that 3 is a common factor of those two numbers. However, we also have to consider the sign. If you don't take out the right sign of the GCF, it will not factor properly. So we're actually going to factor out a -3, and that's because the negative in front of the 15x. Those signs will always match. On the last example, if you look back at the last example, that sign was positive, and so we pulled out a positive GCF. Since we have a minus sign in front of the first or the second group, then we need to pull out a negative GCF. Those signs will always match. So now we have to think about, okay, -3 times what will give us -15x plus 3? Well, -3 times 5x will give us the -15x. And then what would we need to multiply -3 by to get positive 3? Well, we need two negatives to make a positive, so that would have to be a -1. Now notice that we have a common binomial factor of 5x minus 1 from both groups. So we're going to treat that now as a GCF of the whole thing and factor it out front. So we're going to factor out that remaining common binomial factor of 5x minus 1. And what goes inside the parentheses next to that is the x from the first group, which is the remaining factor, and the -3 from the second group. That this polynomial is now factored. Well, that's it for today. These are two very important skills that we'll be learning to use later as we factor different kinds of polynomials. So hopefully you'll put in a lot of practice so that you can get these two skills down pat. We'll see you later.